In order to subnet one network into smaller networks, you need to borrow some bits from the network address that you've been assigned. Let's say the address that you're assigned contains 4 octets. The first 3 you're assigned by Nick. The last one you assign as the administrator. If you borrow bits from this first area here, leaving you the other bits for host addresses, you can use these bits that you borrowed for different subnets. So let's take a look at, if we borrow several of these bits, what we can do. Let's start and say if we borrow 2 bits from our address for a subnet, how many different subnets do we get? If we take 2, we'll first look at all possible combinations. We have 0, 0, 0, 1, 1, 0, 1, 1. You'll notice that I have the words lost written by the item with all zeros and all ones. This is because you cannot use the all zeros or all ones. You're always going to lose 2, the bottom and the top. So what we have left in between is 0, 1, and then 1, 0. So if we borrow 2 bits, we have 2 usable subnets. Be careful with the term usable subnets versus subnets. If you happen to go for some type of Cisco testing, Cisco might ask you how many subnets do you have versus how many usable subnets. Microsoft doesn't differentiate. Typically, they'll say how many subnets do you have, or how many subnets can you use. In this case, you can have 2. Let's look at the possibilities if we borrow 3 bits. If we borrow 3 bits off of our network address, so these 3 bits would be used to assign subnets. These 5 bits would be used to assign host addresses inside those subnets. If we borrow 3, possibilities are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, and 1, 1, 1. Notice the first, the all zeros is lost, and the last, the all ones, is lost. This leaves us with 6 usable subnets. If we'd like to use a formula instead of writing everything out each time we use it, we have a formula that would be 2 raised to the number of bits borrowed minus 2. If we look at the parts of this formula, 2 is because we're dealing in binary. We have 2 choices, 0 or 1. The number of bits borrowed is going to be in relation to how wide you actually want your subnet to be. And then minus 2 because you always lose the bottom and the top range. Let's look at this. If we borrow 1 through 8 bits, we take the formula 2 raised to the 1 minus 2 is going to be 0. If we move up here, 2 raised to the 2 minus 2 is 2. Basically, 2 raised to the 2 means 2 times 2. So 2 times 2 equals 4 minus 2 brings us 2. This, 2 raised to the 3, is the equivalent of 2 times 2 times 2. 2 times 2 is 4, then 4 times 2 is 8, so 8 minus 2 is 6. 2 raised to the 4th would be 2 times 2 times 2 times 2. 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. So 16 minus 2 is 4. Let's look at an example. Borrow 1 bit. 2 raised to the 1 minus 2. 2 raised to the 1 power equals 2. 2 minus 2 equals 0. 2 bits, like I was saying before. 2 raised to the 2 power is 4 minus 2 equals 2. If we borrow 3 bits, we have 2 raised to the 3rd power minus 2. 2 raised to the 3 power is 8, or 2 times 2 times 2. 8 minus 2 is 6. If we borrow 4 bits, it's 2 raised to the 4 minus 2. or 2 raised to the 4 is 16, or 2 times 2 times 2 times 2. 16 minus 2 equals 14. What I'm going to ask you to do is to work through some calculations. If you go to the folder called Stuff and you print out an HTML document that's labeled 03 space borrowing space bits, so 03 borrowing bits, I'd like you to print that out and go through and do the following calculations. First of all, write out all possible combinations of binary numbers if you borrow 4 bits. Remember, you list the first and the last, but write the word lost beside them. Do the same if you borrowed 5 bits. Then after you're done with that, use the formula that I just went through to calculate the number of bits for each of the following.